Right, so over here, without using a calculator, find the fractions a and b. So they are telling us that a and b are both fractions. They are found over here. For which this surd over here can be expressed as a root 10 plus b root 3. So we don't have any more, we don't have a denominator containing surds anymore. Okay, and the only way that we have learned to remove all the square roots in the denominator is by multiplying it with its conjugate surd. So root 6 plus root 5, root 15 minus root 2. It is equivalent to multiplying both numerator and denominator by the conjugate of the denominator. So the conjugate actually makes use of this particular property. A square minus b square is the same as a plus b and a minus b. Today, we are given a minus b. Okay, where a and b, okay, when I say a square minus b square, I'm not referring to the a and b in this question. Maybe to minimize confusion, let me just change it to x square minus y square. So this is x plus y, x minus y. So today in our denominator, we've got root 15 minus root 2, which is our x minus y. If we choose to multiply both the numerator and the denominator, by the x plus y equivalent, which means root 15 plus root 2. In the numerator, I also must do the same so that they remain equal. Root 15 plus root 2. If I do this for both numerator and denominator, my denominator will become x squared minus y squared, where my x is my square root 15, my y is square root 2. So this effectively becomes square root 15 and I square it minus square root 2 and I square it. So of course, when you square a square root, you get back the same number. So we didn't have to bother writing all this. We could have done it mentally, 15 minus 2. That is our new denominator. So the issue over here is our expansion of our numerator. Okay, let's extend this. Do it step by step. Square root 6 times square root 15. That will be square root of 6 times 15. That's the first multiplication. That's the first product. Now next, root 6 times root 2 plus square root 12, and you keep going. Square root 75, square root 10. Okay, and we see that there is a square root 10 appearing already, which is what they wanted us to express it as. So next, square root 6 times 15 actually gives us 90. Now square root 90, square root 12, square root 75, square root 10. I hope you realize that some of these numbers can be expressed as a product of some perfect squares. For example, 90 over here. 90 can be expressed as 9 times 10. Plus, now square root 12, the 12 can be expressed as 4 times 3. The 75 over here can be expressed as, if you divide by 25 times 3. Okay, so this is our another way of expressing the numerator. The reason we are doing so is because we want to square root 9. 9 is a perfect square. When you square root 9, you get 3. Multiply by square root 10. Do the same for the rest. 2 square root 3, 5 square root 3, and square root 10. So by doing so, we see that we have express all the original square roots into square roots 10 and root 3s, which is what the question wants. So group all your like terms together. 3 root 10 plus root 10, we got 4 square root 10. And this is over 13. Plus, we got 2 square root 3 and 5 square root 3. That's a total of 7 square root 3 over 13. So find the fractions. Therefore, A must be equals to 4 over 13 and B is 7 over 13. So prior to this question, when we did our conjugate surds, usually it looked like this, 12 plus root 7. Then its conjugate surd will be 12 minus root 7. Then we had, for example, negative 3 minus root 5. Then its conjugate will be negative 3 plus square root 5. So on and so forth. Now we see that actually it can be done for both square roots also. Root 6 plus, for example, root 5. The other one will be root 6 minus root 5. This is formed from our x plus y and x minus y. Because they are product, when you multiply these two together, we get x squared minus y squared. So the square roots will all disappear. So the concept, there is only one concept over here. And they are giving you 5 marks for this. For your rainbow method when you do your expansion. Quite a good deal. Okay, so now moving on to part B. So in part B, they want us to express 2 to the power 2x equals to 2 to the power 2 again. Okay, sounds familiar. Dot plus 2 plus 21 as a quadratic equation in 2 power x. They're quite kind over here. They gave us a lot of clues already, which they didn't have to. So basically, this 2 to the power x is kind of going to be our, say, y. Okay, let's call this y. Then we're going to try and extract all the 2 power x from this equation. So 2 power 2x, let me just copy it down first, 2 plus x. And as you're writing down, you must be thinking, okay, 2 plus x. When the power is 2 plus x, it means that it is going to be 2 power 2 times 2 power x plus 21. So we are going to extract all the 2 power x out. So here we have 2 power x, and this is squared. Okay, so the powers, x times 2, or 2 times x, you get the same thing, 2x. Equals to, as I mentioned, 2 power 2 multiplied by 2 power x. This is multiplied by 21. We just put some brackets over here to help you recognize and see that we have extracted, we have isolated all the 2 power x. And this can be replaced by another unknown, let's call it y. So this is actually y squared equals to 4y plus 21. Okay, this step over here is not critical. The question did not ask you to write it in terms of y. This step over here should be our answer already, because, okay, after simplifying, okay, so 2 power x squared equals to 4 times 2 power x plus 21. This is our answer for part A. The reason I'm changing 2 power x to y is to show you clearly that, hey, it is actually a normal quadratic equation that we are really familiar with. Okay? So now, find, correct to 2 decimal places, the value of x which satisfies this equation, the same equation. So either you solve this quadratic equation straight away, or if you are uncomfortable with the unknown in the power, you want to solve this quadratic equation in terms of y, you can go ahead and do so. So in the second part, you can say let y equals to 2 power x. After your substitution, we get y squared equals to 4y plus 21. So let's attempt to solve this quadratic equation. Y squared minus 4y plus minus 21 is 0. 7 and 3. We want a negative 4y, so the negative sign has to go to the 7, and we result in a negative 21. So y minus 7, y plus 3 equals to 0. From here we have y equals to 7 or y equals to negative 3. At this point you can substitute back. Y has a value of 2x. So 2 power x equals to 7 or 2 power x equals to negative 3, which cannot be true. Because 2 to the power x is the same as 2 multiplied by 2 by itself x times. So when you take a positive number, you multiply by another positive number, no matter how many times you do it, you will always get a positive value. Okay, so let's take log on both sides. Log 2 power x equals to log 7. So bring the power down. X log 2 equals to log 7. Of course, you can use ln if you want. X will therefore be log 7 over log 2. These are all just numbers. Don't be afraid of them. Key it into your calculator. Log 7 divided by log 2. You get 2.807. Plotting it off, 2.81. Okay, the reason why I'm highlighting that these are just numbers is because I'm afraid you may think that we can further manipulate this to become something like what, log 7 over 2. And then you key this in your calculator, you'll be wrong already. These are not equal. Okay, and this is also not equal to log 7 minus log 2. No, they're all not equal. So as long as you recognize that, hey, log 7 is just a number, use your calculator. Don't go and try any manipulation that you are unsure of. Question 9. A particle moving in a straight line passes through a fixed point O for origin with a speed. Okay, this is our speed. So V equals to 28 meters per second when time equals to 0, t seconds after passing through O. Okay, so we need this information. When the first piece of information they tell you is velocity, most likely it's going to be, you're going to be dealing with integration, differentiation, finding acceleration, finding displacement, so on and so forth. Okay, now they tell us that the acceleration after passing O is given by A equals to negative 16 e power negative 0.5 t. So this is our acceleration. We know that when we integrate our acceleration, we will get velocity. But don't forget that there is a constant. There's an arbitrary constant which we will need to find out what it is. So find the value of t when it is at instantaneous rest, meaning what time was v equals to 0. Instantaneous rest means velocity equals to 0. So what time was it when velocity was equals to 0? Currently we have our expression for acceleration. So we need an expression for velocity, meaning we must integrate our acceleration. So v will be integrating our a, which is negative 16 e to the power of negative 0.5 t with respect to t. You can take out the constant over here, negative 16 integrating e negative 0.5 t dt. Okay, now let's start with our integration. When you integrate e to the power of something, you get back the same thing, but we still have to divide it by we divide it by differentiating the power of e. So when you differentiate negative half t, you get negative half. Okay, we are dividing by the differentiation of the power of e. So next part, we will simply copy down e with its original power. Okay, I'll just pause over here first. You think about it mentally, mental sums. If I ask you to differentiate this, just exercise your brain. Differentiate this. Negative 16, you will keep it, right? You won't do anything to it. Just copy it down. 1 over negative 0.5, you keep it also. You won't do anything to it. E power negative 0.5 t, you will keep it as well. Then you will multiply all this with differentiating the power. When you differentiate the power, you get negative 0.5. Negative 0.5. So multiply all these by negative 0.5. It will cancel over here, leaving us with negative 16 e power negative 0.5 t, which is our acceleration. So these are some mental exercises that you can do to keep on practicing your differentiation and integration. Okay, so this is what we have after integrating, but this is an indefinite integral. There are no limits, there are no boundaries over here, so we must add an arbitrary constant c. So now my velocity is given to be such. We wanted to find what was the time when velocity was equal to 0. So let's exercise our brain again. If I set this velocity to be equal to 0, if I let this be equal to 0, how many unknowns are there? I've got an unknown t, I've got an unknown c. With one equation, two unknowns, I can never solve it. Which means I must find the value of c first. Then I substitute in the value of v, which is 0, then I can find t. So the question, how do I find c? How do we find the value of c? We make use of this piece of information at the first line. The velocity is 28 when the time was equal to 0. Okay, take some time to think about this. The velocity was 28 when time was equal to 0. So when it passed through the origin, did it already have a velocity? Yes, it already had a velocity. It did not start from rest. And here's the tricky part also. Okay, so everybody please look up for a short while. Look up. We are on question 9. We are trying to find the arbitrary constant c from our velocity using this piece of information. Velocity is 28 when time equals to 0. I am very tempted to write, based on this, c must be equals to 28. Is it true? Why not? Are you tempted to do this? I was always very tempted to do this because I know that when time equals to 0, then I multiply 0 with anything, I should get 0 ma. Therefore, my answer for C should be 28. But that's not always true because right now our time is in the power. The time is in the power. So let's see what actually happens when time equals to 0. Okay, so negative 16 multiply by 1 over negative 0.5, e power negative 0.5 times 0 plus c, this should be 28. Let's continue. Negative 16 divided by negative half, that is 32. 32. Now, e power 0 is 1. E power 0 is 1. So this is multiplied by 1 plus c equals to 28. And here we can see that, therefore, the value of c has to be negative. Is it negative 4? Did I make a mistake? C is negative 4. So c is negative 4. Can? So our expression for v is now 32 e power negative 0.5 t minus 4. We're not done yet for part 1. They want us to find the value of t when it is at instantaneous rest. Meaning, when v equals to 0, what is the corresponding value of t? So when v equals to 0, 32 e power negative 0.5 t is equals to 4. Now just manipulate until you make t the subject. Dividing by 32 on both sides, e power negative 0.5 t is 1 over 8. Let's take ln on both sides. And at the same time, I want to bring the power down. So negative 0.5 t, ln e I don't bother writing already. So this gives me ln 1 over 8. Recognize that this is simply a number, ln 1 over 8. No need to be afraid of it. So t has to be dividing by negative half on both sides. Negative 2 ln 1 over 8. This is the exact value. So let us evaluate. Negative 2 ln 1 over 8. So the time is 4.1588, 1.89 to 5 SF. And we round this off to become 4.16 seconds. So at time 4.16 seconds, the velocity was 0. So either it stopped there or it made a U-turn. Next part of the question, find the distance when it is at instantaneous rest. So we already have the time that it was at instantaneous rest. Of course, when you're doing your subsequent calculations, please use this value. Negative 2 ln 1 over 8. Because it is exact. If for any reason you want to use the rounded off value, use the 5SF. Never ever use the 3SF value. Otherwise, you'll lose your accuracy. So when time equals to negative 2 ln 1 over 8, what was its distance from O? Notice that they said distance from O. They are not asking for displacement. So suppose you do your calculation, you know when you integrate your velocity, you get displacement, right? And then after you get your displacement, you substitute in the value of time, which is 4.1589, you get a negative value. Suppose you get a negative value. That means that the displacement is negative. But because they want the distance, you will have to modulus it to get positive value. Now if you were to calculate the displacement using the time, and the displacement is positive, then good for you. That will be the distance as well. So now we need an expression for displacement first. And that is given by integrating our velocity. So this is our expression for velocity. We will need to integrate this. So the answer for A, let me just write it down. Negative time equals to negative 2 ln 1 over 8. So now we want to find the displacement expression. So integrating this, let's do it straight away. 2e negative 0.5 t minus 4 dt. Put in the brackets. 32. Divide, okay, 1 over, so divide by, differentiate the power, negative 0.5. Copy down the same e to the power of negative 0.5 t. Now minus 4, you know that it will be minus 4t, and we have another arbitrary constant. So early on we already used c. So here let me use c1 to differentiate, to show that there's a difference between these two c's. So here we get negative 64 e power negative 0.5 t minus 4t plus c1. Okay, so same problem again. I've got another arbitrary constant c which I want to get rid of. Let's see whether we have any clues. Particle moving in a straight line, blah blah blah. Okay, so it was after passing through point O, they start timing. Meaning when time goes to 0, it is at O. And our displacement is with reference from O. So what this over here means is that when time goes to 0, displacement equals to 0. That doesn't mean our C1 equals to 0. So let's continue. When S equals to 0, T equals to 0. Or when T equals 0, S equals 0. Doesn't matter, same thing. So we have 0 equals to negative 64. Now e power negative 0.5 times 0 is just 1. So we have negative 64 multiplied by 1. Please do not write negative 64 times 0. Okay, now we have minus 4. Over here we finally have multiplication by 0 because this is a polynomial. Okay, it is linear. Multiplied by 0 plus C1. Now we can find out the value of C1. C1 equals to 64. So our expression for the displacement is negative 64 e negative 0.5 t minus 4t plus 64. Recap, the question wanted the distance from O when it was an instantaneous rest, meaning when time equals to negative 2 ln 1 over 8. So let's do a substitution. When time equals to negative 2 ln 1 over 8, S equals to okay, so this is what we have. I know that this portion will result in a non-exact value. You're going to have a lot of decimals from this part. Over here, I think we can find out an exact value. Okay, we can find an exact value here, but this will be non-exact. So, do you want to go through the trouble of really evaluating this exactly? Knowing that eventually you will still need to run off because this portion is to 3SF. That means you use our calculator to key everything in. That's first option. The second option is recognizing that this portion, hey, there's a chance that we can, with the E, there's a chance that we can find an exact value for the very first term. Because we've got a e power ln. My advice is don't go through that trouble unless you want to practice. So just straight away, key everything into your calculator and you will get the answer after rounding off to 3SF to be 39.4. Okay, after rounding off, this will be 39.4 meters. And it is positive. So good for us. A circle has the equation, so on and so forth. Find the coordinates of the center of the circles and the radius of the circle. Okay, either you go and complete the square, which I encourage you to, or you memorize the formula. So we know that the center is going to be x coordinate first. Look at the coefficient of, check that the coefficient of x squared and y squared, they are both 1s. Only then can we straight away write down the x coordinate of the center as negative, you change the sign, 6/2. The y coordinate is, change the sign again, we've got a negative 4, so it becomes 4/2. So the center is negative 3, 2. Very good deal. Okay, now for the radius, this is question 10. For the radius, it is given by square root. This is if you want to memorize. We're going to square this negative 3. We're going to square the 2. We're going to add them up. So negative 3 square plus 2 square. And we're not done yet. It's 9 plus 4. 9 plus 4 is 13. Then we're going to subtract this value. So this is a negative 12. We're going to subtract this negative 12. Effectively, we're going to be adding it. Okay, so this is the formula. We end up with 9 plus 4 is 13. 13 plus 12 is 25. Square root of 25. Okay, we have a integer as the radius. The risky thing about using this, although it is very short, is that you may mix up the formula for finding the radius, or you may mix up finding the x and y coordinates, which happens quite often to me. So this is actually not my preferred method unless I'm desperate for time. Okay, next, find the coordinates of the, okay, that's done already. Show that the equation of the tangent to the circle at the point is so on. Okay. When it comes to showing tangent is a certain equation, a few things should come to your mind. Tangent, okay, tangent to a circle. Is this going to be a discriminant question, where our b squared minus 4ac equals to 0? Is it going to be one of this? Or since it is tangent, maybe dy dx, then with find a gradient at negative 7, then we continue from there? Or maybe something else. Okay, so these are the things that have to go through your mind. So let's start with our discriminant. Okay, is it reasonable to use our discriminant in this case? Well, our discriminant can be used if you have the equation of a circle and you are given the equation of the straight line. So if y equals to mx plus c and y equals to ax squared plus bx plus d, yes, you can equate both of them. Then you find the discriminant of the resulting quadratic equation. Then you can find the x coordinate. But that is not what this question is asking for. They are providing you the x coordinate. They want you to show this equation. So you cannot be using our discriminant over here. Let's move on to the next option. We've got, we could consider dy dx. Suppose we differentiate this. Are we able to differentiate this with respect to x? Meaning, can I make y the subject over here? Because if I write this as y equals to something, then yes, I can differentiate with respect to x. But you see that you can't. Or rather, you haven't learned. There's a y square over here. How are you going to differentiate this with respect to x? And then you've got another y over here. They appear in the same equation. So we are stuck. We can't use differentiation in this case. Is there something else that we could have used? So at this point, sketch. Sketch a circle. We've got a center as negative 3, 2. So the x coordinate is negative 3, radius is 5. So my y coordinate, my y-axis should be somewhere here. X, okay, sorry, the y coordinate of the center is 2. So this is my x coordinate. This should be 2. And this is -3 with radius of 5. Okay, so this is my sketch of the circle. And at point P, -7, let's say this is -7 and -1. Okay. So -7, -1 is over here. This is point P. -7, -1. Tangent to this circle at this line. Draw a tangent line. They want you to show that this line has equation of 3y plus 4x plus 31 equals to 0. Now with this sketch, I see clearly it is a tangent to a circle. What else have we learned in mathematics about tangents to a circle? And I've got a center of the circle. Is there a particular line that you can draw to help you? What line is that? You can join these two lines. And that is our radius, right? The radius will be perpendicular to the tangent. Very sneaky. They sneak in a question on perpendicular lines and their gradients over here. So what we are expected to do is to actually find the gradient of this line, of this radius over here in blue, which we can do so. I've got the coordinates of the center, I've got the coordinates of P. I can get the gradient of this radius. Now since this is perpendicular to the tangent, I can find the gradient of this tangent very easily. It is the negative reciprocal of the gradient of this radius. Once I have the gradient of this line with one set of coordinate, I am sure I can get equation of the line. So this is the thought process. Of course, during the exam, you have to start eliminating the first option of discriminant quickly. You have to start eliminating the option of this differentiation quickly. Then come with this plan by yourself. Okay, so let's begin. The center, let's call the center C. Let center be C. So now I want to find the gradient of CP. Gradient CP. Gradient of CP will be, this is -3, 2, y2 minus y1 over x2 minus x1. 2 plus 1, -3 plus 7. So this is 3 over 4. Yep, so don't forget your plan. Gradient is 3 over 4 over here. So gradient of tangent line. Gradient, tangent is going to be negative reciprocal of this. So -4 over 3. This line has gradient -4 over 3. Using the coordinates, y equals to mx plus c, so -1 equals to the gradient -4 over 3 times the x coordinate, which is -7, plus, okay, so since I've used c earlier on already, please don't use c anymore. Use some other value for the y-intercept, d. So evaluate, we manipulate so that we get the value of d. -1 minus 28 over 3 equals to d. D equals to negative -31 over 3. Okay, so put this back into our equation for the straight line. Equation for tangent is y equals to gradient negative 4 over 3 x minus 31 over 3. But it is not exactly in the form that they want. The form that they want didn't have fractions. So multiply throughout by 3. So 3y, then since they have it as equal to 0, move everything to the left hand side, plus 4x plus 31 equals to 0, shown. So the tangent is done. The next part of the question. The point Q lies on the circle again. Same distance from the y-axis as the point P. Same distance from the y-axis, this is our y-axis, from the point P. If it is the same distance away and it lies on the circle, logically it has to be vertically above. This is the only point on the circle where it is the same distance away from the y-axis. No other point exists. So if it is vertically above, I know that the x coordinate has to be negative 7. Okay, not just that. Obviously, you must find the y value, right? If I have the x value, how do I find the y value? Huh? How do we find the y value? Okay, so everybody please look up for a moment. This is question 10 on the circle. We have the coordinate of P, negative 7, negative 1. We know that Q is directly above. It has an x value of negative 7. What is the fastest way to find the y value? Maybe I don't ask you what's the fastest way. What are some ways we can find the y value? I've got an equation of a circle. It was x plus 3 square plus y minus 2 square equals to 25. So given the x coordinate, can I substitute to find the y value? Yes, you can. So that's one way. But is there a faster way? Like really, really fast. Can we use the symmetrical property of a circle? How about this? If I know that this value is negative 1, and I know that this value is 2, what do you think this value is? 5? Can you see that it is 5 straight away? Because there are 3 units over here. So by symmetry, this must also be 3 units. So this y coordinate is 5. You don't believe you can substitute into the equation, you will get 5 also. Besides getting 5 when you substitute into the equation, you will also get negative 1. Because these are the two y values when x is equals to negative 7. Okay? So now I know the point Q has these coordinates. Then finding the gradient shouldn't be a problem also. Okay, we can use similar methods to whatever was done in the previous part. Again, this will be perpendicular. I can find the gradient of this radius. Negative reciprocate, get a gradient of this line. Using the coordinate, find the equation of this line. So that it will be the answer for part 3, 4 marks. Finding the equation of this tangent line. And part 4 is a giveaway. Find the coordinates of R where they intersect. Once you have the two equations, I'm sure you can solve simultaneously to find coordinates of R. Last question, 11. Find the coordinates of A, B, C, and D. This is the equation of the curve. Now this curve has two portions. These two, they fall under the same equation. So the first point that we can find quite easily is when x is equal to 0, to find point A, sub x goes to 0. And a, x equals to 0, y equals to 3 minus 12 over 9. So this will be 3 minus 4 over 3. Three minus 1 and 1/3, we get 1 and 2/3. 1 and 2/3 is the same as 5 over 3. So the coordinates for A will be 0, 5 over 3. So the coordinates for D must also be something, 5 over 3. Since AD is parallel to the x-axis. Now we want to find we can start to find the value of x coordinate for D by substituting 5 over 3 into the y value. So at D, y equals to 5 over 3. Okay, do the substitution. 5 over 3 equals to 3 minus 12 over x plus 3 squared. I'm sure you can do this by yourself. You'll find that the x value for D is -6. So next we have to find the x coordinates. These x coordinates happen when y equals to 0. So at C and B, y equals to 0. So do the substitution. 12 over x plus 3 square equals to 3. X plus 3 square is 4. X plus 3 is plus minus 2. X will be -5 or -1. This is -5, 0, -1, 0. Wow, 6 marks. Area bounded by the curve AB and the coordinate axis. Please read the question carefully. I'm sure some of the students, when they were attempting this question in the previous years, they thought that they're asking for the shaded region, but it is not. They are asking for this portion. So this will be integrating for part 2, area from -1 to 0, 3 minus 12 over x plus 3 square with respect to x, and put in brackets. Do the integration by yourself. Set in the limits, and we have part 2. Oh, it's just 1 unit. 1 square unit. Okay, this is a very basic, straightforward integration. Last part, part 3. Okay, this is the last time I'll be asking you to look up. Everybody look up. Question 11, part 3. Area of the shaded region. We found that this yellow part is 1 square unit. If you want the area of the shaded region, there can be a few ways we can do it. But we have to find the fastest way that is acceptable. How about we form a rectangle by symmetry? This is also 1 square unit, right? Then we can find the area of this rectangle. The y value, the height of this rectangle is 5 over 3. The length of this rectangle is 5 units. Then you minus away 2 lah. Then you get an answer. Okay, so no need to integrate for part 3. That's all for this paper.